right now. Might have to. Okay, I'm gonna log out real quick and go.
Trayvon. There you go. Stay with us, buddy. You can tell he's laying down.
Yeah.
Yep. Bye, Trayvon. Or somebody.
Adios.
Keaton, you in the kitchen? Okay. What is that? A nice cup of hot tea you got going on there?
Nah, it's cold. I'm fixing me a bagel.
He looks like a bagel.
There's Tariq. He's back. Tariq, our guy, we lost our guy who was giving the safety meeting. What's up, Tariq? Unmute, buddy. Unmute.
Cam Rogers is going to be a little late.
Okay.
He just sent a message.
Can you guys see it?
No, sir. I see you.
I see
Yeah.
You said
Now we see it. Yeah. Go ahead.
Okay, hold on. Let me.
I'm okay. It's instant. Welcome to Pike Electric's live line demo. Pike Electric is a power line contractor out of North Carolina. Mount Airy, North Carolina is our home headquarters. We are a full service provider for our customers, meaning that we engineer, we build substations, we also build transmission lines and distribution lines all across the United States. We also are a final stage manufacturer of bucket trucks and line trucks. And this truck you see behind me here was actually built there in Mount Airy, North Carolina in our fleet division. On the truck today, we have David Staggs, Joe Cox. My name's Andy Cleary. We all work in the safety department at Pike Electric. At one time, we were all linemen out in the field. Right now, we all work in safety. This truck you see right here, we have 3 of these trucks that run across the United States in different places for our customers and also our employees. The primary reason we built these trucks is to raise the awareness of working safely around electricity. So we're going to show you some things today. Hopefully you can take back with you, make you better linemen, make you work more safe around electricity, and also to raise that awareness of working and dealing with every day some of the dangers that's hidden working with electricity. To explain our truck, this truck is basically a rolling substation. We're getting our power from 12208 coming up through that 90 cable there, out that transformer. Right now we're working on low voltage. What you see here, the power poles, the wire is the same thing you see outside, feeding your homes. The middle pole you see right here is a recloser. This recloser, we're going to show you how it operates. The recloser is actually a fuse that can actually count, and it counts each time it's put on the line.
Great.
You see a cutout at the top?
Yeah.
Can you pause it?
Bypass for the
Professor V, did I hear correctly that he said he's running 12208?
208. That's what I thought he said.
Guys, how do you run 12208 on single phase? Has anybody got an answer to that?
I might need a bigger fuse. That's all I can think of.
No, we're talking voltages, not amps or anything like that. Does anybody think that we can derive 120 and 208 from single phase?
Oh,
No.
No. So we're off to a good start here. 120, 240 single phase.
yep.
Okay, carry on, Tariq.
for the recloser. On over to where Joe's standing, we have another cutout, have a transformer. Also on the back side of that pole, we have an underground line that feeds like underground developments and businesses and things of that nature. We're going to show you what happens when you make contact with the buried line. And also on the back of that pole, we have an outside light. Also have a light right here. This green light means there's power to the truck. When I squeeze this trigger, red light will come on, indicating there's power on the line. You ready? So we have power on the line. A few problems that power companies have and co-ops have is animals getting on top of transformers and knocking out the line. And we have Sammy the squirrel here today. He's going to make his debut here. He's going to show you what happens when a squirrel or an animal makes contact with an energized transformer. It's going to be a loud noise, so prepare yourself for that. You ready? A lot of people, when they hear that noise, they automatically think, hey, my transformer blew up. But actually what it is that fuse, that there's a fault on that transformer, and that fuse will blow. The lineman comes out, he refuses the transformer, gets the power back up. The middle recloser, the middle pole here has a recloser on it. The recloser is designed to operate when there's a fault on the line. In normal operations, that recloser will operate 3 different times. And on the 4th time, if that fault hasn't been cleared, it will stay out. We're going to put the recloser through a fault situation. If you listen real closely, you can actually hear the recloser clicking and counting each fault, each time that fault hits the line. You ready? Come back to the recloser here in just a minute and show you one other thing that a recloser will do. On the back side of that pole I showed you earlier, there's an underground line that's simulating the underground. A lot of power companies, most power companies, co-ops, municipalities do use a line like this to feed underground. It carries primary voltage. We're going to show you why it's very important that you get your locates before you do any type of excavating work around your home. And this stick right here represents a shovel. That employee puts his foot on that shovel. If he doesn't have that locate, or it could be that backhoe out there digging. That's why it's important to make sure you call and get the proper locates before you do any digging. You ready? And again, a loud noise, the lineman will come out. Most of the time they'll find the trouble. It takes a little bit and they'll fix it, get the power back on. Going back to our recloser where David is. This recloser has a second option or second job. It's also called a one-shot. And David put it on one shot. Linemen that's working out in the field, moving primary lines, reconductoring, things of that nature, are required to put this device on one shot. And what one shot means, if there's a fault on that line, it's going to go out one time, the first time.
Did we lose sound?
I think we lost it on the video. I don't think I could still hear him in the background. Say something, Tariq.
Or taking the
Very
line, taking the recloser off the line. They're going to establish a visible opening on the line.
What happened?
You're good. Keep going.
Okay.
And Joe's going to test the line for voltage. Make sure there's no voltage on the line. Next thing we're going to do is install a ground on that line. A lot of customers wonder why it takes so long to get the power back on. In some situations, our guys got to work safe. We got to protect our linemen. Our linemen are installing these grounds on the line for protection of the employees out there working. Also, David is hanging the tag on the recloser, tagging that device out. And also is going to hang a flag on the grounds, on the line next to the grounds, indicating visibility for the grounds. This is your typical lockout tag out or flag tag and ground situation right here. The next part of the show, the guys are gonna have to switch the transformers around just a little bit. They're gonna come off the truck and we're gonna retest the truck and make sure that we have no bleed over. You notice David and Joe both have all their PPE on. They have their hard hat, safety glasses, their gloves and sleeves, FR clothing, and also their overshoes. Because this is a live situation. We're getting ready to switch it over to primary voltage, and we'll be drawing some arcs and things of that nature. Our rubber gloves and sleeves, we have a test lab in Mount Airy, North Carolina, at our home headquarters. We actually test our own rubber gloves and sleeves. We test them by the OSHA standards. In some cases, in a lot of cases, we succeed, those OSHA standards on dielectrical testing the rubber gloves and sleeves. It's very important our linemen take care of these gloves. OSHA requires a daily test of our testing that glove and also a visual test of that glove to make sure there's no holes in it. When dealing with hazards, you always want to try to eliminate the hazard first. If you can't eliminate the hazard, you got to find a way to protect yourself from that hazard. And our gloves and sleeves are our protection for that. Along with our cover up, our rubber line hoses and our blankets that's on the truck, they all work in conjunction together with PPE.
Sound's gone again.
Leaks on the ground. Says,
All right.
Zero. Next thing we're going to do is step up on the truck and we're going to actually read the primary voltage of this line. I'll tell you what the primary voltage is. 6,300 volts. So anything over 600 volts is considered primary voltage, and we're way past that. So right now we're going to be dealing with primary voltage. You notice we have a tree here. Trees are really nice. They're real pretty to look at. They also can cause a problem for power companies and co-ops. They actually grow up into the line. The wind blows maybe the tree over, lightning hits the tree, and it causes a lot of damage. I want you to pay close attention to this, ladies and gentlemen. If you would, look at the top of this tree. This is a tree making contact with 6,300 volts. Now, if you would, look at the bottom of this tree. This would be where the employee would be standing, or the customer would be standing, cutting the tree off the line. It's about 11,000 degrees in 1/6 of a second. Just to prove the point of how conductive trees can be, we're going to remove the cutout on the far pole there. And we're going to bridge that cutout with a small tree limb, a tree limb that actually came off this tree right here, and see if we can get the light to burn. See the light's coming on. That's just a small tree limb. You can imagine a whole tree, how conductive it can be. This is going to simulate an antenna. Years ago, back in the 70s, there's a lot of TV antennas up. Now we have cable vision and satellites and things of that nature. But there were a lot of people injured, during that time, installing TV antennas or CB antennas. This could be anything around our home that's conductive. So always make sure that we are, very aware of our surroundings when dealing with, working around anything that's conductive when it comes to power lines. If you would, watch this here. Look at the top of this when it makes contact with 6,300 volts. Now watch the bottom. Again, always be aware of your surroundings when working around your home and your business for power lines, overhead power lines. The next part of the demonstration, we're going to demonstrate a power line that could be laying off the pole onto the ground. And a lot of people have a misconception when it comes to it. They think, hey, that power line's, it's broken, it's laying on the ground, it's not energized. But this here is going to show you that a line that's lying on the ground can very well be energized. It can actually insulate itself, and no one will know it until they go to pick it up. I'm going to energize this. You see our light behind Joe is burning. It looks harmless, doesn't it? Look what happens when Joe goes to pick it up. Also, a lot of power lines have a thick insulation on it around the conductor, and it could be laying on the ground energized and no one would ever know it. So always be aware of any power line on the ground. Make sure you treat it as energized. Do not touch it. Do not try to move it. Next part of the demonstration, we're going to demonstrate a kite string. How many of us like to fly kites? I'm sure this crowd, maybe a few of us, we're a little bit old maybe, but we have kids at home that love to fly kites. And we're going to show you just how conductive a small kite string can be. And all we have here is your basic, kite string that came right out off the roll. We're going to show you how conductive this string can be. See our light is burning? You imagine a small kite string that conductive. Imagine rope like this rope in front of me right here. This rope, you may think it's non-conductive, but what happens after we use it a time or two? It gets dirty, it gets oily, gets wet, and it actually can become a conductor, just like a kite string. These balloons that Joe is holding right here is called a mylar balloon. Mylar is kind of a thin aluminum. I'm going to show you how conductive a mylar balloon can be. Conductive enough to pick up the coils of the transformer and energize the light. Next part of the demonstration, actually, this looks like a ladder, has a tire on it. This can represent our bucket truck, our boom truck, or even our own vehicle when we strike a pole. A lot of guys think that maybe because that tire is rubber, I'm okay, it's insulated. If you would, watch this demonstration here. Watch the bottom of this tire right here. See if you see any fire coming off of it. And one thing we do at Pike Electric, all our equipment, bucket trucks, line trucks, even this truck right here you see, has a ground on it. We take that ground and it's bonded to the frame of that piece of equipment, and we actually take it and put it on the neutral line of the power line we're working on and ground this equipment. That's what David is doing right now. He's installing his ground on this piece of equipment. Then he's going to take it and put it on the system neutral. Always have good continuity, make sure everything's good and tight. And at this time, we're going to put it back into the primary. We're going to show you how good our ground system works. If you would, I know you want to look at the top of this, but look at the bottom where the fire was a few minutes ago and see if we see any now. Ready? Didn't see any fire that time, did you? The ground system, that's the reason we ground here at Pike Electric. OSHA says you can either barricade like this or ground your equipment, and we ground our equipment. And your ground is only as good as its weakest link. Always make sure your ground system, your grounds are in good shape, good and tight. The surface contact, make sure it's good and clean. Take a wide brush and brush it. Next part of the demonstration, we're going to show you what happens, what can happen when the human body comes in contact with the power line. Now, we have a hot dog that represents the human body. A hot dog is made up of a lot of water, just like the body is. Our body is made up of a lot of water, a lot of tissue. Always keep backed up hot dogs with.
Mm.
The human body is made up of a lot of water. You have a central nervous system already in your body. So when the human body makes contact with a power line, there's a lot of damage there. There's always the chance of the heart stopping because every contact is normally hand to hand or hand to foot, right in the direct path of the heart. So this is what could happen if the human body makes contact with the primary line. Ready? Our rubber gloves, we have a rubber glove here that actually has a pinhole in it. Also has a hot dog in it representing the hand. We're going to show you why it's very important. Our linemen, every time they go to use that rubber glove, they do a test of air test and also a visual test on that rubber glove to ensure there's no hole in it. That was a small pinhole earlier. That's the size of the eraser head on the pencil now. We have these volunteer firemen in the crowd. There's usually one or two in every crowd. We have a fireman's boot. A lot of firemen think because they have that boot on, because that thick rubber sole, that I'm going to be okay. But what's inside that rubber boot is a steel shank, and that steel shank's in there for protection. So we're going to show you what happens when a fireman boot makes contact. David, close your cutout. Close that cutout. Here at Pike Electric, our linemen are required, anytime they're working around anything energized, make sure they have their overshoes on. Our overshoes are for incidental protection only. And what I mean by incidental protection is, in case a line becomes energized or say a piece of equipment becomes energized, and that employee would happen to be leaning against that piece of equipment, these overshoes are for that type of protection right there, incidental protection. If you would look, this overshoe here actually has a small hole in it. We're going to show you why it's important our linemen inspect their overshoes. See the fire at the top. Now we have a good overshoe. It's not a brand new overshoe. It's actually an overshoe that's been worn. It does not have a hole in it. I'm going to energize this. You guys ready? Our light's on. There's primary voltage. Do it again. There's primary voltage on that overshoe. You don't see any fire. And that's the reason we wear overshoes at Pike Electric, for protection, for incidental contact. Well, that concludes our demonstration. I hope you guys have enjoyed it. There's one thing to keep in mind: electricity is safe to work on. You got to respect it. And all your PPE, all your cover up is the tools that you need to use every day when working on energized lines. Thank you for your time.
Trick, you got anything you want to add to that, or?
Welcome to Duke Energy.
Not really.
Today we're going to give you a demonstration on our what we call our hotline trailer.
Who's that, me?
My
That's
name's
good.
Ed Flowers.
Oh, hang on.
Been with the company.
All right, we good.
You good?
Yeah.
Anybody got any comments or anything? Anybody see anything going on there that they don't 100% agree with?
Yeah,
I've got a couple things.
yeah.
I mean, even if a question came up in your mind, well, why did they do it like that? Anybody got any comments on that?
Not really. That's because I'm wrong.
All right. Well, I'll go right about the first quarter of that video right there. And Professor V, you let me know what your procedures are also as far as Duke was concerned.
Okay.
We weren't allowed to test for the presence of voltage as a test to use phasing sticks unless
Right.
we tested the sticks with an applied voltage. So what I mean there is get your phasing sticks out, test it on a voltage to make sure you get a voltage reading, then retest the line to see if you get a 0 reading. Does that make sense to y'all?
Mhm.
You got to test the sticks that you're testing the line with first to make sure that they're working before you de-energizing the line. That's why we went and used tick tracers or hot horns first. They're reliable, and those are easy to test.
Mhm.
Yeah, and they're making an audible tone. So you're going to get an audible tone and a light when you turn it on, and it's going to be just a slow beep, 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 like that. As soon as you get it towards anything energized, it's going to make a solid tone. Just stay with that tone all the time, and the red light's going to stay on all the time. That was our line test for presence of voltage. And then you can go ahead and ground it. I didn't particularly agree 100% in their procedure there of testing it with phasing sticks
Mhm.
and then going immediately to grounding. Now, can you test it with a tick tracer, test for non-presence of voltage, and go straight to grounding?
Mhm.
Is that allowed?
Yes.
Yeah.
Yeah, that's fine. You can do it like that. But testing a line for presence of voltage with phasing sticks without testing the sticks first to make sure they're working correctly, I don't 100% agree upon. How about you, Professor V?
Yeah, same thing.
Okay.
Same thing.
Okay.
Yeah.
Anything that you saw, Professor V?
Just a couple comments about what I observed in here, just to remind you guys of, just like when he showed the ladder, the little simulated ladder with the tires, and it drew the arc. Guys, just that, to me, that simulates a man up in the aerial bucket working on primary voltage. You want to stay off. You want to stay off the trucks. Don't put your hands. Don't lean up on it. Don't sit up on it, because the tires do not insulate like they're saying, because most of those tires are steel belted, and of course that's going to go to ground. I've seen many cases where dump trucks raise their the dumps up into the primary, blows the tires out on the truck, scares the guy half to death. So those kinds of things you just want to be aware of. Just because it's a utility truck, don't mean it's 100%. It may be dirty, not cleaned in a while or something, but anyways, just kind of stay off those trucks whenever they're working on primary, that kinds of things. So very important to remember. And a lot of times these trucks are barricaded off, just like what he said, whenever they get on primary. I know a lot of trucks will put some kind of barricade around the trucks when they're working on primary. And that lets people know around the truck that, hey, don't go near the truck because it could be energized as well.
Mm-hmm. Yeah. I want you to hold right there, because that really leads into my second part right here. If your company is requiring for you to wear overshoes,
Yeah,
you got to wear overshoes.
yeah,
I hate to say it. I am not a proponent for overshoes.
me either.
How do you test them?
Yeah.
I don't know. Okay. You're going to be stepping on sharp objects. Those things are going to get dirty. They're going to get full of water. And one, it goes back to what Professor V was saying, is it gives you a false sense of security. Well, yeah, I can go up to the truck. I've got overshoes on. No, you can't. You still can't do that. We did not use overshoes.
We didn't either.
All right. And the way he put it, he called it incidental. I got it written here. Incidental protection of contact. So if you didn't wear overshoes, really our thought process were exactly what Professor V said. Don't put yourself in a situation for incidental contact. That's pretty much it. Don't lean up against the truck. Don't lean up against the fence. Stay away from objects that are, got booms in the air and whatnot. And we already talked about step potential. If there is a wire on the ground and you cannot determine if it's energized or not, shuffle away. All right. So companies are going to require them. That's fine. When we went up to New York to do that storm damage repair, that company did require us to wear overshoes. Do we have any? No. And we just explained to them we don't have overshoes and we don't have incidental contact. We're going to be okay. So they let us go ahead with work.
Yeah. Most of the places you saw wore the overshoes were the contractors. Some utilities, I'm not sure if they even require their guys. They used to wear them all the time. Pike, Lee, those kinds of contract utilities, they wear the overshoes.
I can guarantee you on a stormy, wet, or icy day, those things are coming off anyway. They are slick.
Exactly. The last comment I'll make is about grounds. You guys just remember that the grounds that they were using in the simulation, they are part of your PPE, and you need to take care of your grounds because, I mean, if you've got a bad set of grounds, our grounds were tested once every 2 years. They came around and tested them, scrapped the ones that didn't, meet the criteria for the testing, and they were tossed, and we received new grounds. But you just want to make sure that those grounds are kept in a dry, clean place away from the oils and anything that might damage them, and they are to be cleaned before being put on the line. So very good part of your PPE as well is your grounds.
Right. Uncoil your grounds. Don't use a coiled ground.
Right.
Okay.
Okay.
All right, Professor V, we're at 9:35. What would you like to do?
Take about 10.
Okay, sounds good to me.
Then we'll jump on street lighting.
There we go.
Okay.
All right, see you guys in about 10 minutes.
Guys, we're going to get back rolling again here. We got a little bit of stuff to go over today with, we're going to do some lighting. This is going to be real close to finishing up 231, but we're going to start off with the lighting part, and Professor Beckers are going to go over our switching and line isolation. So if you got your book with you, go into look at page 741. That's on chapter 19, outdoor lighting systems. I'll give you a minute or two here maybe a minute to get your book open and get on the same page so we're all looking at the same information. And just to let you guys know that there is going to be a quiz today on lighting. So take you some notes on what we're going to talk about. And it's really good information to know here. So
Page number again, please.
741.
Thank you.
Okay. All right, guys, if you got your books ready, let's hit page 741, types of outdoor lighting or the applications of outdoor lighting. Outdoor lighting can be street lighting, roadway lighting, sports field lighting, airport runway lighting, and traffic lights. And I'll add one more to that, and it is called, what we used to call at Duke is called area lighting. And most of that concerned or dealt with residential lighting, just residential customers having area lights in their backyards or in the front yards, wherever. While electrical utilities tend to work only on street lights, other lightings are discussed in this chapter because linemen can be called upon to work on all kinds of outdoor lights. And we do. And guys, outdoor lighting is probably one of the main revenue sources for a utility. I know it was put on a great emphasis was put on lighting with Duke Energy, far as the sales, what we call sales of lighting, repair. You wanted to keep those customers happy because they're paying for those lights. You wanted to make sure they're working at all times. But it's just a common thing with all utilities that.
Keep going. Keep going.
We good?
Yeah, keep going.
Okay, that we maintain all this stuff. So, and that goes for municipalities, little cities, large cities. They all pay a great sum of money, every month for lighting, for their street lighting purposes. I remember when I got to see, I used to have privilege to the town of Andrews billing for the street lighting that I maintained, and they paid somewhere in the neighborhood of $20,000 to $25,000 a month for their lighting in that small town. So these major cities that have this lighting, they pay, you know, lots and lots of money every month for the lighting, and it's important for us to maintain that lighting. Santee does 4.2 million a year. That's a lot of revenue for any company. I mean, it's just something that it may not go out of light, and it changes. I mean, just like we're going from incandescent bulbs now to LED, and we'll talk about that more in a minute, but the more they get into this lighting business, the more it's developed into a more economical system for them. The more they pick up on it, the more money they make. It's just it's a win-win situation for the utilities. Street lights were one of the earliest forms of load for the original, for the companies. And guys, I'll tell you this, and I used to tell customers this all the time, not only just street lighting, but area lighting, because whenever the crime would start to rise in a neighborhood, they would look to us. I'd have to go out and talk to a customer and say, and they would ask, well, does lighting, keep crime away from your house, away from your neighborhoods? And that's a twofold thing. Yes, it does, but sometimes it really depends on how bad enough somebody wants to, to do something illegal. They're going to do it regardless of the light. It's either going to, deter them and keep them away, or it's going to be right there to help them see what they can take or what they can do to, steal or whatever. So depending on your situation or the customer's situation, whether they want it or not. The illumination of street lights improves safety, pedestrian safety, security of people and property. Municipality normally owns and is responsible for the street lights within its jurisdiction. And that's true. Whoever municipalities do that because most of them own their own power system. Private companies rent out these systems or sell these systems to different companies. The rates are fixed, they're flat rates. And I'm not sure with Santee Cooper, but with Duke, it has to be approved through the public, what do you call that? Public Service Commission.
Yeah,
Is
agreed.
that true with Santee
Agreed.
Cooper?
Yeah, because back in the early 90s, light pollution came along. So yes, I agree.
Yeah, so that's all regulated by the government as well, how much a company can charge a customer. All right. And those rates depend on their many variables of ownership of the pole, type of pole, whether it's served overhead, underground, type of luminaire, size of the lamp, type of maintenance contract. All these things are figured into what the customer's cost is going to be for the light. Now, when these lights are installed, there are various types of voltages that serve these lights. The most common is 110. That's the most common type of voltage that serves these lights, but it can go up to 240, 208, 277. And those lights that can handle those multi-type voltages are called, multi-tap ballast. And just like at some high schools, we serve lighting in those parking lots and the roadways going in. They are served by like maybe a 277 480 underground transformer. And a lot of times you have to go in there and have 277 or 480 in a light, which can be dangerous at times. You really want to de-energize those types of high voltage lights when you're working on them. I've seen some guys go in there and not do that, and because you're working in such a confined space, short something out in there and cause a flash or cause a burn to a part of your body, your face, or whatever. So just be careful with those voltages and know that, and you might see this again, that 110 volts is the most common voltage that is used for lighting. All right, over to page number 742, we talked about street lights. That's one type of application. Roadway lighting and we didn't do a whole lot of roadway lighting in our areas other than like on ramps and off ramps on major highways and interstates. When you got into like the Raleighs and the around Florence or Greenville and those areas where we served those really busy highways, at that point, they would go in and install lighting to those types of roadways, and that's another big area for you to maintain, or the companies to maintain, because those are, especially at night, those are high speed areas, and want to keep the lights going as much as you can. All right, sports field, and it says area lighting. We talked about area lighting. We didn't do at Duke a whole lot of sports field lighting. Normally that's done by municipalities or cities. They take ownership of their own, the complex for the sports fields. How about with Santee Cooper, Professor Shoemaker? Did y'all maintain those as well, or? We just normally maintained the step down transformers into a ball field, but we didn't do anything on the fields.
No, that's all private. We didn't mess with ball field lighting.
You're looking at runway lights. We never messed with runway lights. I know you all did it one time, correct?
We did until 9/11.
9/11.
Yeah,
correct.
simply put, I mean, the airport would call us. We'd take care of their lighting, and we'd charge them back.
Right.
Right.
Yeah, we never got into the business of working on anything that had to do with the runway. I guess there was some legalities involved with that, with working on that stuff, making sure it was, constant all the time.
Right.
Traffic lights, we didn't get into traffic lights. Usually that's handled by DOT or one of their contractors. And you'll see now, especially with Duke, I don't know what Santee Cup or a lot of the other utilities doing, but Duke is actually contracting all their area lights out. And I see these same companies that are working for Duke with these traffic lights. They are actually contracting out with DOT as well here in the States, and in South Carolina, working on traffic lights as well. And there are several other utility or contract utilities that do this kind of work as well. So traffic lights are generally not for the Dukes and Santee Coopers and all these companies. Now we have assisted DOT. There you go, American Lighting. That's the contractors, and you see those contractors around in this area, and those guys do a pretty good job, coming in. So I mean, that's a really good company to go work for, from what I understand. So
this is a national company, and they have a ton of employees. That's all they do, lighting and signalization. The last time I checked with them, depending on the state of South Carolina, they started at 1810. Wow. And their jobs are constantly rotating. You see, I didn't see any for South Carolina, but you've got North Carolina, Pennsylvania, Florida, North Carolina, Texas, Georgia. Wow. I mean, it goes on for a long stretch right here. You also find in most of these companies that you're working, and Professor B will get to it in just a moment here. What do you think their hours are?
10 hours.
They'll typically run a 10-hour day. What do you think? What time do you think they start?
6, 7.
Probably right around midnight.
Oh, okay.
They'll start at midnight, and they'll do their own patrols and catch lights out and repair them at night. And whatever they didn't fix at night, they'll fix during the day from the previous day. I mean, this is a real big, reputable company.
Yeah.
So I just want to let you know, see by that screen right there, that there are contractors, and I just picked this one because they're the biggest.
Yeah, and they do a good job, and like you said, and it's best for them to work at night due to especially 4-lane highways. They get so busy, and a lot of people just don't pay attention, and with the distractions out there with cell phones and everything else, it's a better fit for them to go out at night and work on these lights. Sometimes we did patrolling for them at night to determine which lights were out, and we'd mark the poles with some kind of red or yellow flagging to let them know which lights were out, and they could come back and do it. But kind of getting away from that, and I know Duke was getting away from it as well. Whenever I retired, they were, going into the contract side of that as well, bringing ALS in there to work on the lights. And that was a lot of my work that I did during the day was working on customers' area lights and street lights. And you got a class A lineman out there making $38 to $40 an hour, and that's expensive for him to go out there and work on a customer's area light or street light. And it's just more, I guess you could say it's more efficient or more effective for a utility to contract this out to another company. They don't have to go in there and pay for benefits or anything else, and they can get the same work done at a cheaper price, and that's more in the pocket for the utilities. So that's the way it's going. I'm not sure Santee Cooper's rolled that way yet, but that's what Duke does now, and it actually frees up that man to be able to go do line work, what he was trained to do.
We have not gone to they have not gone into that contractor rotation
Right.
use yet, but they will rotate 2 people for 6 months on a streetlight crew.
Okay.
And they will work those hours. They'll work from 12 midnight to 10 during the course of the day. Then they'll rotate those 2 people out, and 2 people will get rotated into the streetlight crew for the nighttime. We also, and I've spoken with some of you before, we also had an incentive.
Right.
That if a patrolled light, either by us or a called in light by the customer or a called in light by the city has got policemen and maintenance people, they look at lights too, that we had to have that light back on within 72 hours.
Correct.
So and we recorded the times that we had repaired it, it was reported, and when it was repaired. If we did not make the 72-hour time, that customer got that light cost free for that month.
Wow.
So you can see where money gets tied up in this. Nice.
That's a good deal. Most companies that you see out here in the the real world, they don't do that kind of thing. They don't give those kinds of incentives. They just wait on somebody to call in, or like you said, so you ride by at night and see one out, and then you go to fix it. So that's a good incentive. Most of these lights that are installed are looked at by the engineering departments of these utilities. They'll send out an engineer to look at it because they're different. Like you can see on page 743, there are different types of lights and different types of light patterns that are put out by these lights. And usually it's better for an engineer to go out and do these surveys on somebody's property to see what is best fit for them. Not really sure what type 1 through type 5 are, other than it may be like type 4 looks to me like it's a floodlight. Type 5 may be multiple lights on a pole shining in different directions. Same with 1 and 2, 2 and 3. Well, all of them look like they could be multiple lights, which way they're shining, the type of lights they are. They put out different light patterns. So that's best left up to the engineer to suit the customer's needs. Light pollution is a very real problem in a lot of places, especially over here at the beach. What they do certain times of the year, I know down at Pawleys and some of the more outlying places, because of the sea turtles that migrate to these areas during the year, they either put shades up on the back side of these lights, or they turn them off, because it just disorients the wildlife out there, and it messes up their patterns for laying their eggs. So light pollution is very real. I know years ago in downtown Raleigh, they wanted to get a handle on it, so they took all the floodlights down, and they called them Cobra Heads at the time. That's the lights, and I'll show you one here, a Cobra Head. I'm gonna share my screen. Here, share. And I'm going to here. That's a Cobra Head. That's a cutoff light, a fixture. They actually went to these types of lights. Can you see that okay, Phil Shoemaker? That light?
Yeah.
Good deal. That's a Cobra headlight. That's what they went to because it basically shines the light straight down in a kind of like an egg-shaped pattern. It did not illuminate the light up in the air as does. That's a LED. That's this. This is an open bottom or a semi-enclosed light. They did away with all these kinds of lights, and this is the Cobra head right here. You can see how it pushes light out and up, as well as this one here and this one here, and it just kind of, and you can see this. You guys seen it before, riding down the highway at night, and you're maybe outside of Conway or something, and you can see all the lights at Myrtle Beach, or you could see it at Florence or Raleigh's or Atlanta. If you've ever traveled toward Atlanta at night, you can see that city off in the distance. It's still, an issue, I think, where there's a lot of pollution out there, but they've got a better handle on it, installing these new lights that are out there.
Yeah, while you're on the pollution side of it, it's a natural to nature pollution that's going to be going on too.
Yep.
You're actually going to be polluting yourself. So if you see the picture that he's got up here, he's got that white bright light that's on that one pole. If enough light comes out of illumination of that, it's going to blank out the pole on the left.
Yeah.
I mean, by blank out, that light's going to think it's daytime by the light that's given off by the other light.
Right.
So you got to watch it internally also, not just for the natural causes, but what you're doing to your lighting system to yourself.
Yep. Okay. All right. Down at the bottom, number 3, there are mounting height restrictions in some municipalities and cities, and most specifications, there are specifications made by these utilities where they have certain pole heights for certain kinds of lights. And there's actually 5 types of poles that lights are installed of. And you remember this, guys? You have wood poles, steel poles, fiberglass poles, aluminum, and concrete. Those are the 5 kinds of poles that you're going to see out in the world for these utilities. And I'll repeat them again: wood, steel, fiberglass, aluminum, and concrete. And the most common type of pole is out there in the field, in the real world, in utilities, is they use wood poles the most. That's the most common type of pole that's used out there in the industry. Anywhere from, with us, it was the shortest pole we would put up is like what we have on the field. It's a 30-foot pole. The picture I showed you with the open bottom light, that was generally the light that was installed on these poles. The steel poles, fiberglass, aluminum, concrete were mainly used with underground applications. The wood poles could be used with either underground or overhead. It did not matter. But the utilities charge for these types of poles. A wood pole would, at Duke, per month charge concrete, fiberglass, aluminum.
Thank you.
Mm-hmm. Duke charges on a regular 30-foot pole for area lighting. They have to pay, the customer has to pay $2, and I think it's $2.25 a month charge, and they have to pay that through the duration of their contract period with the utility for that wood pole. Now, if there was an existing wood pole close by their property and they wanted a light installed on it, there was no charge, because that's what they call an existing pole, so existing facilities. So the 5 types of poles, again, is wood, steel, fiberglass, aluminum, and concrete. Any questions about those kinds of poles, guys, or what they're used for? Okay. All right, we'll go to page 744 now. And we're going to look at luminaries, lamps, and structures. A common type of luminary or fixture is a single self-contained outdoor light used as a yard light, street light, or area light. It consists of a ballast, transformer, a lamp, which is a bulb, capacitor, depending on what kind of light it is, whether it has a capacitor in it or not. And these are all self-contained, and it is activated by a photo control or a photocell. If you guys can see what I'm holding up here, this is what a photocell looks like. And it works either off 120 volts, 240 volts, and it is actually connected into the top of the light or wherever that mounting is by these prongs that you see on the top of our photo control. And it, like I said, it can be either 120 volts, 240 volts, 277, depending on the voltage and whatever this photo control is rated at. These are very cheap to maintain. A lot of times when you see lighting that is burning all the time, we call it day burners. If you see a light burning all the time, the majority of the time it's going to be a bad photo control. And this is very cheap to replace. I think they're like just $5 or $10, depending on the type, the heavy dutiness of the photo control. And they have a good warranty on it. The ones we had at Duke that were bought had a 5-year warranty on the photo control. And if it went bad between the time it was installed and that 5 years out, you'd get a 2-for-1 replacement. You send it back to the manufacturer and they would send you 2 back. So good piece of equipment, cheap piece of equipment to turn lights on and off at night. As well as that, these lights, when you install them, you won't be able to see it on here, but what I'm looking at on the top of this photo control, it has a north facing arrow on top of this photo control. And when you install this light, this photo control needs to be aimed towards the north. So it'll turn itself on just at dusk, and it'll turn itself off at the break of daylight. And that's very important. You want it to come on as late as possible, and you want it to turn off when dusk comes into play in the mornings.
Yeah, there's no reason for a light to be burning while the sun's up.
Correct.
So you want to take advantage of the direction.
That's right.
Also in a photocell there, you're talking about warranty. You turn that thing upside down where the prongs are at. I know you probably won't be able to see it on the screen.
Yeah.
But inside, well, you almost see it right there. You see all that drawing and stuff that's going on. How do I know when I installed it? Just take your knife and there's a month and a year. You make a little hash mark by that. It'll show you like December to 2021. So whoever takes it back down knows when it was installed.
Correct. Good point. So the question is going to be, what turns the light on and off night and day? What turns the light on? Did you go out there and turn all these lights on at night, or what controls them?
What controls the on off? Yep.
Photocell.
Yep.
Motor control. That's right. And actually, if you can see it here, it has a little window, and it's got a circuit board within that window. And whenever the light hits it, it activates that circuit board and cuts it off. And when there's an absence of light, I mean, it lets the light come back on. It closes that circuit for the light to be able to come on. Okay. Any questions about photo controls, photocells, and how they work?
I got one question.
What's up?
In the case of light pollution, they be adjusted?
Yes, they can be adjusted. And what we did with light pollution, like Professor Shoemaker showed in that picture, if there's an adjacent light that's burning and it's burning bright towards that, you can actually turn this window, adjust this light away from that light that's close by it. Or what we used to like to do was we'd put a piece of electrical tape across this window, move it across this window where it wouldn't allow that light to come in. Now this light it'll come on a little bit earlier in the afternoon, and that's fine too, but we wiped out that light pollution. And that was done either by adjusting the photo control or putting a piece of tape across the window.
Gotcha.
And what direction do we normally point the photo control? Anybody?
North.
What direction?
North.
North. Okay. Good job. We want to make sure that that photo control, if we can, point it in the north direction.
And guys, you're not going to be out there with a compass. You know, just get general north. It
Yeah.
doesn't have to be exact.
Right.
I got a quick question. Where's my whenever you said what controls the light on and off, what did we come up with there?
What did we just talk about?
I missed it. I had
Oh, sorry. A photo control, photocell.
Okay. Thank you.
And that's the majority of the lights, yes.
Okay.
Some of them do have different kind of relays on like street lighting, and they are controlled by photocells as well, but it has a different type of component that operates like if you've got 100 street lights out there, it's controlled by one circuit, you know. Okay. Any more questions? Okay. Let's talk about, let me see my quiz here. Let's talk about lamps. They're actually getting away from the lamps that you see out here now. These fixtures that require lamps, they're actually going away from those and installing LEDs. A LED light does not have a bulb in it. LED is actually like an electronic circuit board within that fixture that emits light, and it's a bright, clear light. And there are different types of lamps out there, different types of fixtures. You have a sodium vapor bulb that's out there. You have a mercury vapor bulb. You have a high pressure. And sodium is either going to be high pressure or low pressure, one of the two. Mercury vapor, and then you're going to have the LED, of course, we talked about that, and then a metal halide. So actually, there are 5 kinds of lamps we need to look at: high pressure sodium, low pressure sodium, mercury, LED, and metal halide. And like I say, a lot of companies are going away from them, and you'll notice, you may have noticed or may not have noticed that coming into the school on the side by our climbing field, they actually replaced a lot of these fixture types with the LEDs now. And I mean, it's cheaper to operate, and it's more efficient now.
Right. By my notes over there, I just want to make sure everybody's seeing my type out. Sodium vapor equals 2. They're both yellow. High pressure sodium, that's the HPS, and low pressure sodium, that's LPS.
Okay. Now let's talk about we've got the different types of lights that are out there. Let's talk about how do you distinguish between the types of lights that are out there. Now, as far as high pressure and low pressure, high pressure is going to have a yellow tag on it. Low pressure is going to have a green tag on it, and I'll show you what I mean by tag in a minute. Mercury vapor is going to be a blue tag. And guys, I tell you, mercury vapor is going away quick. They're doing away with those because it has mercury in them. The government came to Duke Energy several years ago and said, you guys need to go away with the mercury. And actually, that's the way they incorporated the metal halide, because that mercury vapor is like a white or a blue light, not a blue light, but a clear light or white light. And the metal halide is a clear white light. Mercury vapor, like I said, is blue. LED is a white tag. And then metal halide is a red tag. And that's how you determine what kind of light it is. And you can determine it pretty easy looking at the fixture from the ground.
Do you still have that picture up of the ones that you?
Yeah, let me go back to that and I will show you guys.
I mean, this gets vitally important, especially if you're getting on a crew that's patrolling lights. Obviously, we don't want to get out the bucket truck every single time. Well, what kind of light is it? So he's going to tell you right here. We'll show you right here. That will do the ones you had.
Which one was that? Right there.
That one too.
Yeah. Okay. You can see in the bottom of it. This is a Cobra fixture. It's got a flat screen inside of it right here, or shade. But you can see this yellow tag. What does that mean if it's yellow right here, guys?
What kind of light is it?
What kind is it?
Sodium.
Sodium vapor, high pressure.
High pressure sodium. There you go.
High
Green
pressure
is low
sodium.
pressure. Yellow is high pressure. So you know it's a high pressure sodium light.
And two, as well, you can tell, and we'll go into this in just a minute, what size bulb goes into the light. How big is that fixture? And you can see that 25 on there. So what size light would you think a 25 is?
Wattage.
Wattage wise?
500.
No. 250 watt. 25 goes with 250. And I'll stop sharing. If Professor Shoemaker, you can go back to your note screen.
Okay. Yeah, this is really simple other than one component that goes on here. Hold on one second.
Right.
To identify in these lights. So let me get back up here. You call them out to me, Professor V, and I will type them in.
And this is the wattage chart, guys, and you'll see this on the test as well. You'll start out, if you see a 10, a yellow 10, and that's going to be 100 watt. You've got a 15, that's 150 watt. A 17 is a 175. A 20 is a 200 watt. 25 is 250 watts. You've got a 40 watt, which is 400 watts.
Oops.
And then an X1, which is 1,000 watts.
X1 equals 1,000 watts. X1 is the only one that kind of throws you off.
Yep, that you got 100 watt on that one.
Sorry, thank you.
1,000 watt. And it may be, and like I said, especially the number 17 you got there, which is 175, that one is going away because that is specific to a mercury vapor light and it's going away. But there are still some of these lights that are out in the field. The X1 can go either way. I've seen that on a mercury fixture and a high pressure sodium as a 1,000 watt fixture. But if it's a mercury vapor, it's going away as well. And it's going to be replaced with LED. There's still tons of high pressure, low pressure sodium lights that are out in the field today. And these companies have to work on them well. So, I mean, customers still pay a price for them. The 100 watt light, usually a customer pays, I think with Duke, they're paying like around $10 a month for these lights. I've got two of them in my yard. I pay, and it's kind of funny because Co-op does it a little bit different with their rates. I've got one that I think I pay $7 a month for. It's been there a while. Then I had another one installed, and because the rate had changed since I had that one installed, I think I pay like $9 for the other light. So with Duke, when the rates changed for the light, it didn't matter if you were paying $5 for it. 15 years ago, that rate's going to go up with the rates that are applied at that time. So it will change on your bill with the private utility. Is Santee Cooper the same way, or how do they operate?
It will. And, speaking in previous classes right here, there's a computation going on. Lights are not metered.
Right.
So they've got to figure the lifetime of the lamp, the lifetime of the head, the luminary itself, the lifetime of the pole. A lot of computation goes into this, and it's spread out over the year they expect the lifespan of that light to be, and they come down with a monthly charge for that. Now, eventually, you're going to run into some lights. I think the sodiums, as far as life expectancy. The 100 watt ones are a real long time, that eventually you will have paid for everything,
Right.
including the energy charge for it. And the company will start making money off of it because you've actually paid for everything that's up there already. That doesn't mean the bill's going to stop.
Right.
The company is just getting icing on the cake
Right.
in that process.
And that's like we do for a regular area light that you're gonna put in overhead in the customer's backyard. That you're gonna have to agree to a 3-year contract with that. And anytime within that 3 years, you decide that you don't want that light anymore, you've got to pay 70% of what's left on that contract to buy out of it. And usually after that 3-year contract period, the cost of the material versus the cost of labor, all that's added in and figured, is paid for within that 3 years, but you're going to still continue to pay that cost.
Right. Okay, on my notepad over there, I just put real quick to ask, if I have a red tag with an X1, what's going on there? What kind of light do I have? Red
What
tag,
kind of light?
Metal halide.
right? X1.
How many watts is it?
Oh, 1,000.
1,000 watt.
There you go. There you go.
Right.
Yeah, you guys get the concept going in here. And while we're sitting in this situation and talking about color coding and wattage, I cannot take in any one of these situations here. There are 400 watt sodium bulbs. There are 400 watt mercury vapor bulbs. There are 400 watt metal halide bulbs. I cannot interchange bulbs in heads. Does that make any sense?
Right.
I cannot take a 400 watt sodium lamp and put it in a 400 watt metal halide light. The lamp is specific to the head type. You cannot interchange. Does everybody understand what I'm saying there?
Yes, sir.
Okay.
Okay. Good deal. All right, now that we've talked about the poles, different kinds of poles we got out there, we talked about the different types of light heads themselves, different size, different wattages. Let's talk about the different types of heads we've got out there in the industry. We have Cobra Heads, and we showed the picture of the Cobra Head just a minute ago on the screen. We have a rental fixture.
I'll unshare so you can show that one. I know you got it ready.
I've got it right here. Nope, that ain't. Come on, get off the screen. Rental. Is that what you all called the rental at Santee?
Yes, sir. And it goes, the terminology goes right to what you hear in the name of it. A rental is meant for a person to rent. So usually you'll see this in a backyard or side yard. So the customer is renting this light.
And different companies have different names for them. We call these a semi-enclosed or open bottom light. And it's all the same, and it's all being rental. Can anybody tell me what kind of light this is? What size?
I can barely make it out.
It looks like a 10 up there. So what is that going to be, guys?
100 watts.
What kind?
1,000 watt.
No,
1,000 watt.
a 10.
100 watts.
10, 100.
100 watt.
And it's
100
yellow.
watt.
Sodium.
Sodium, high pressure sodium.
Yes.
Yeah, remember,
High pressure sodium.
the only thing that presses into when you get over 1,000, you get that extra digit there, you're going X1.
X1, correct. Okay. So we've got Cobra rental, shoebox. A shoebox light, guys, if you notice the lighting in the parking lot where you guys park next to the training field, those are shoebox lights out there. That is one different kind of light that, and that's a good light for parking lots and those kinds of things. You'll notice those in grocery store parking lots, the Walmarts, and you'll notice those shoebox are being switched over to LED shoebox as well. So shoebox is a type of light. We have a floodlight. I know Professor Shoemaker's going to note on this while I'm looking for a picture. A floodlight would be similar, would be kind of like Let me scroll through my pictures, guys. It would be similar to this right here, this application here. This would be a LED flood right here, but it'd be very similar to that, a regular floodlight. And I don't see any in these other pictures right here. But anyways, the floodlight, LED.
There's one that will scroll down. No, on the other side. Right there, bang, yellow and orange, gray and orange picture.
Gray and orange.
Yep, it's got a whole bunch of heads in it.
This one.
Yep, there's your flood.
Yep, that's a LED. Let me get, I think I got rid of one of them.
There you
Right. There you go, LED flood. And then a LED Cobra, and that would be this application. Okay, or this is the LED flood. Either that or that. And you'll see a lot of places in a lot of cities, they're doing downtown revitalizations right now, and they're down at, I think Myrtle Beach is going through it in different phases. They're converting lines from overhead to underground, and they're actually going in and putting these styles lights in for lighting. They're decorative lighting. They cost a little bit more, but they look good. Aesthetically, they look good, but they're expensive.
Yeah, they're grossly expensive, but the customer pays for them.
Customers paying for it. The city of Myrtle Beach is paying for those lights monthly. And they probably have to pay a one-time charge as well to have this stuff installed, because it's very expensive to convert from overhead to underground.
Yeah,
They have a lot of those in Market Common.
Yes.
Yes. Yeah, lots and lots. There's hundreds of those.
And that's an extreme area for light pollution. Those poles are typically concrete, the one he's got his mouse over.
Right. Yeah. Some of them you will find that these are on 16-foot fiberglass poles. You'll have 4 feet in the ground and 12 feet out of the ground. And guys working on these lights, you cannot lean a ladder up on these fiberglass poles to work on them, because they will break off with you. So just remember that. So we got the 6 types of heads, and I'll stop share on that. Okay. 6 types of heads: Cobra, rental, shoebox, flood, LED panel, and LED Cobra.
I've got decorative.
You got a decorative light on there as well?
Yeah.
All right, we'll add a decorative to it.
Okay.
You said LED panel?
LED panel, that was the flat panel where it shines straight down.
Okay.
That's a LED panel. I might have called that a LED enclosed light or Cobra Head or something like that, but it's actually a LED panel light and a LED flood.
Okay.
Okay. Okay. What time we got?
I just texted you.
10? Oh, you did? Okay. 10:30? Did you text for a break, or you want to roll on?
I'll just let you know what time it was.
Okay. All right. Let's finish this stuff up.
Sure.
Because I know we're going to go into that. Okay. We talked about lamp color codes. We talked about the head types, the pole types. We talked about photo controls. Let's talk a little bit about troubleshooting these lights. We talked about light pollution, troubleshooting. Let's talk about the steps for troubleshooting a light that is cycling. Can anybody tell me what cycling is, what that term means? What do you think it is? If you ever rode down into, or you might have had one of these lights in your backyard, and it'll come on, then after a while it'll shut down, cool down, then it'll come back on. It just does it. That is cycling. That when a light is cycling, it's on and off, on and off, on and off. Drives people nuts. They hate it. But for a cycling light, these are the steps that we're going to use for troubleshooting. The first thing we're going to look for, we talked about, is light pollution. Do we have a light that's too close to this light that's causing that photo control to operate on and off? Is it that? It will rule that out. And then we'll go into, go up to the light, cover the photo control, and you want to give it a few minutes to see if something's going on with the photo control. Cover it up and see if the light's going to come on. If the light doesn't come on, then you want to replace the photocell. If the light still does not come on, then you want to look at the lamp. You want to replace the lamp. If it's not the lamp or the bulb, that's what we call the bulb, it's the lamp, then we want to replace the head. So go into steps for cycling, for a light that's cycling. Light pollution, look for that. Cover the photocell, replace the photocell, replace the lamp, and then replace the head. Those are the steps for troubleshooting a light that is cycling.
Some of these sometimes can be company specific. Sometimes some companies, and we did get into this for a little bit and it didn't last very long. The company started buying us the pieces of equipment that actually go in the head, like a ballast and a startup capacitor,
right,
starter, and all these pieces. And they asked us, well, start replacing pieces in the head, just don't trash the whole head.
Right.
That went away pretty quickly. Didn't last very long because it was just too time consuming.
Yeah.
But if your company says it's got a different policy, well, I want you to repair the head before you take it down, you can just do what the company asked for. Right. The other part is here, I cover the photo control, doesn't work, so I replace it. That still doesn't work. I replace the lamp, and then it does work. You're not going to go back and put the old photo control back.
That's right.
Okay. Whatever you replaced up to the point of finally fixing it, leave it. All right. Companies, is a photo control is how much? $7?
Yeah.
Yeah. If you've done that work to replace it, just leave it there. You got a brand new one there for the future.
Correct. And if it's if you're working with a company that recycles this stuff and it's still in date, send it back in to have it replaced,
Yep.
Okay. Okay. Now we talked about looking at troubleshooting a light that's cycling. We're going to troubleshoot a light that is completely out. Okay. The first thing we're going to do when we go up this, and I did this all the time, is cover your photocell. Okay. If it does not click, if it's not working, replace the photocell. All right. If you've replaced it, the light comes on, then you're good. But if not, when you replace that photocell, it's clicking, there's no action on the bulb, it's not blinking or coming on, you want to replace that lamp. Get that lamp out of there, guys. These lamps do burn out just as photocells, like Professor Shoemaker said, have the dates that you can scratch into the top of these photo controls. Bulbs have the same thing on the side of the little copper ring on the side where it screws up into the fixture itself. You put the date in it when you install it. It's up under warranty as well. So if the lamp doesn't work or the bulb doesn't work, replace the bulb. If that doesn't do it, like Professor Shoemaker said, if whatever your company policy is, if they say put a new fixture up, put a new fixture, but the next step you want to do is check that ballast out, okay, after the lamp. Lamps have ballast, they have starters, capacitors, depending on what kind. You got to look at that stuff that's hooked into that ballast. So replace the ballast. If none of that works, check your voltage. Make sure you got the right voltage coming in. You want to know what your voltage is coming to that light. You either check it inside the head itself, or you check it at the connections where it's at the bottom of the bracket where it comes up into that light. Make sure you've got good voltage. And I'll tell you one thing, what'll fool you sometimes, if you have a light that's not working and you go up there and check voltage, it may give you a good voltage of 120 volts. So what you want to do at that point is cover up your photocell, get that light up under load, and then check your check your voltage. Usually it'll drop pretty fast, maybe 60 volts, 50, whatever the voltage is in that bad spot in that wire, or bad connection, it's not gonna make that light work. And a lot of times that photo control will just sit there and click. It'll click a lot. So check your voltage under load and without the load.
Right, and that's vital. I've seen a lot of guys go up to the light and have gone to this point and check the voltage and say, yeah, it's 120, it's great. And the simple thing to do here when you're going through the process, when I say when he says cover photo control, is have an extra glove.
Correct.
Extra leather glove, it fits right over the top of the photocell. So pretty much, that light's going to be on all the time until you take that glove off.
Right.
You can screw a lamp in, by hand, and it'll light up.
Yeah.
If you want to de-energize it to check your ballast and capacitor, just take the glove back off. So
Yeah.
you haven't got 4 hands. You haven't going to have to go back and forth, cover it, uncover it, cover it, uncover it. And especially in this part, when you're checking voltage under load, make sure you got that glove over the photo control, then check your voltage. If it's trying to draw amperage, you're in a good space.
Right. Okay. All right, if the voltage is good, and all the other stuff is, you've changed the photo control in the bulb, still can't get it to work, you're going to replace that fixture. Okay. So replacing the fixture is your last resort. You want to disconnect the voltage going to the light and change it out. All right, let me check. The last thing I'm going to talk about here is lamp disposal.
Huh.
Different companies have different policies as far as lamp disposal goes. At Duke Energy, they have 55-gallon drums with a very thick liner, plastic liner that we put in it. And that's where the bad bulbs go, because they go to be recycled. What they do is when I say recycle, they dismantle the bulb, crush the glass, take the metal out of it. If it's a mercury vapor light, they have to very carefully get those harmful particles out of those bulbs to get rid of that mercury as well, because they don't want to put that back into the environment. And if you look at some of these other bulbs that's out there, they'll have a little ball of mercury floating around in it to make them work. I know there's some metal halide bulbs as well that have a little dot of mercury in it. So all these things are taken into consideration. Wherever your company says to dispose of these bulbs, dispose of them properly. We kind of did some stupid stuff kind of coming up. We used to kind of play baseball with them. We'd take a pole stake and we'd pitch these old bulbs and bust them in the trash cans, do kind of stupid stuff, but that's not really the way you want to go with it.
There's no sound like a 1,000-watt bulb, which is probably the size of a football.
Yeah.
Busting inside a trash can. Man, that's cool.
Yeah.
Yeah.
And then all that goes into the landfill, and it's bad for the environment. Okay. So you just want to make sure whatever your company requires you to do, you store them in a safe, secure place that whenever that bin gets full, they send it to the recycling facility.
Yeah.
Yep.
Oh, normally what's going to happen out there is you're going to get a new lamp in a package, a paper cardboard package or something like that. Just take the old lamp, put it back in that package that you just used for the new one, and lay it nicely in that recycle bin.
Correct.
Right. You're not having to do any work as far as reclaiming gas or all that kind of stuff. Other people take care of that, but they do not like to see a bunch of busted lamps on the back of your truck or at the service center where you're supposed to put them.
Correct. Okay. Guys, y'all got any questions so far about lighting and how to troubleshoot and how to repair? Like I say, everything nowadays is going LED. You'll see these changes coming about. And actually, I think LED lighting is a little bit more, they charge a little bit more for it because the fixtures themselves are, a little bit more expensive for companies to put up, and they're going to pass that cost on to the consumer. So it's bad for us, but good for them. So
Okay, you see me typing down here in the
I do.
bottom, and this is how proactive they got about it. They gave incentives for employees that came up with ideas to help lower costs for the company. And I had one. And in 2002, lighting, just outdoor lighting for Santee Cooper consumed. And what I did is I went and I asked the engineers, give me every single light that's on the system and the wattage. And then I added all that wattage up per night. And guess how much it was? 24.2 megawatts. Now that's every single light on the Santee Cooper system. That's how much consumption there was of watts per night. And that really translated into one substation transformer. How much does a substation transformer cost?
A lot.
Yeah, you're looking at a couple $1 million for that. So, you know, incentives came out, and this is a good point where Professor B's talking about LEDs. If you lower that, and we're going to talk about another part of it. If you lower that wattage usage, one, you're saving a ton of money. And two, if you lower it enough, you might save a substation transformer for having to be built.
Yeah.
That was our concept. Now you go into LEDs, there's a difference between wattage and lumens. Does anybody know what lumens is?
The brightness of the bulb.
Brightness, right. There are lamps out there, and that's why you see us see a lot of companies moving to the white LED. That a white 100 watt LED is brighter than a 200 watt high pressure sodium. Brightness in lumens. So of course, there's going to be a lot less energy usage in an LED overnight. Photo control spotting, just like Professor V has said earlier, that's a savings. And they are now getting into the technology of having Wi-Fi.
Right.
On every single one of your photo controls. So it's not determined by the sun, it's determined by time.
Right.
Wi-Fi will turn your lights on and off at night. So, you know, we're taking a whole lesson right here talking about lighting. Guys, there's a ton of money involved in this right here.
Right.
And utilities are really, really proactive about one, providing what the customer needs, and two, being cost aware in that process. Lighting is expensive.
Yeah, it is. It is. Fellas, y'all got any questions about lighting? Professor Shoemaker, should I read through the quiz real quick without answers, or?
That sounds like a plan. We'll just make sure we got everything square.
Okay, all right. So guys, I'm gonna read through the questions. Don't answer them. Let's just read through them. And if you got any questions when I get done, let's just ask your question. Name the color codes for high pressure sodium, mercury vapor. Hang on one second. Let me pull this up. Name the color for, high pressure sodium, low pressure sodium, mercury vapor, metal halide, and LED. We want the color codes. How can you determine the wattage of a light head from the ground? What are the 5 types of poles out there that lights are installed on? Can you interchange lamps between the different types of lights? What part turns the light on at dusk and off at sunrise? And one thing we did not talk about here, I see it's on the test, on the quiz, is the type of wire size that feeds the lights. Normally, it's a number 12 copper that feeds the light. Let me make sure that's correct in what I'm telling you.
You're right. You're right.
Okay, number 12 generally. And you have 2 different colors in there. You have a white lead, which is your neutral, and it's grounded at the same time in our system. And then you have a black leg, which is the hot leg, the 120 volt leg. And that was the next question. What color scheme for wires feeding input into the light? All right. What is the typical voltage feeding the light? We talked about that. When a light goes on and off, what is that termination? What is that terminology for a light that is going on and off. It says name 4 types of light heads. I think we got what, 7?
Yeah, we got 7 because they expanded.
Okay,
We'll change that question.
we'll change that to name 7 types of light heads. What directions do the photocell window face? We talked about that. How do you adjust the photocell? Let me get that so I can read the whole one. How do you adjust the photocell to have the window face away from light pollution? There's what, 3 different, how we deal with light pollution? 3 different answers for that. Photos, I'll go through that real quick. We rotate the photocell. We can use some tape on it. Or what was the third one there, Professor Shoemaker? It's a static insert.
Yeah, the shading.
The shading, yes. We did.
They actually make little windows, like, well, they're sunglasses.
Yeah.
Sunglasses that you can put in the little window of that thing. It's kind of strange.
Right. Okay. Name 4 types of light heads. We did that. That was, I'm sorry guys, to go double up on that. What's the procedure for lamp disposal? How do you dispose of that? We just talked about that. And what is the procedure for troubleshooting a light? There's actually 14 questions. Okay. Guys, any questions about the questions?
I
Okay.
think I had one, but I forgot. I totally forgot it.
Okay. I'll give you a second.
I can't even remember. Sorry.
Well, I'll tell you what, Professor Shoemaker, do we want to take a break? I know we're probably going to go over a little bit today, right?
Yeah.
Let's go ahead and take about what time? 10:50. Let's come back at 11 o'clock. Tariq, if you think of your question, just shoot it at me or shoot it at us.
We'll get back into it. And really, there's no quiz or anything on this today. What I'm going to talk about here is preparing yourselves for what we're going to be doing out in the field. Out in the field yesterday, we made a what we call like a pseudo loop, a loop of primary. And let me get a share screen going on up here. Share screen, and we're going to go to Untitled Paint and share. Okay, y'all see that?
Yep.
All right, so what we've done out there in the field is we've got a pole configuration like this. And at each location, and I haven't double checked it since yesterday, I don't know if it was complete or not.
Yeah.
That did not come out right. Those little S's that you see right there, this pen is not working correctly. These little squigglies that you see right here, I'm trying to draw in that are for some reason not being kind to me. We've added switch locations. So a switch at every point in the line. What is going on here? There. I don't know. All right, so we have a loop. And the purpose of us going into this is, one, it gets pretty technical during the course of switching, is that you're going to have to work with your dispatchers and your fellow co-workers out there in the field as far as communication is concerned. It's in the process, you're going to be given an instruction. You have to repeat that instruction. You're going to have to get verification that that instruction was received. Then you're going to perform the task. You're going to recall and let them know that that task was completed. They're going to confirm that task was completed. And then you're going to carry on and affirm that situation. So I know it gets kind of long and cumbersome in here, but there's a lot going on as far as this process is concerned. One of it's for safety, and the other part of it is for the process of not having any power off. So the first part that comes into this right here, and Professor V will probably help me in this communication process, is, let me stop share that one, is moving an open point. So anywhere where you saw in that loop of primary where I had a switch, we're going to start with an open point and we're going to have to move that open point to another location. We're going to give you the full processes right here. I'm going to type it out for you of what needs to be done for that to take place. So share screen. Let's share my Untitled notepad. Share. Okay, you should still see the old light stuff on it, right?
Correct.
Okay, that's okay. We'll leave it there. So let me come down to the bottom. I'm gonna call it switching.
Okay.
Move, open, point. All right, in order for this to happen out there in the field, we're gonna have to make some adjustments to our system to be able to perform this. I cannot, and here's a cardinal rule. To move an open point, you must close and open point first before opening OPENI new point. Okay, that is a cardinal rule, because if I do my new open point first, I'm going to have a whole section of line off, because now I've introduced two open points, and you can't have that in a loop section of line like we got out in the field. All right, so here's the processes. We're going to use two different circuit breakers, and they're going to be the same for everybody: SRA and SRB, which really stand for Singleton Ridge A and Singleton Ridge B. In order to close an open point, we must first breaker, BREAKERS, must be in manual. What do I mean by manual? We talked about it before. It's essentially what? See me typing?
Hotline work permit.
It's essentially a hotline work permit, okay? If we have any kind of problem that goes on while we're doing our switching, the breaker's going to go out immediately, okay? Regulators on both breakers matched to 120 volts. So I have to match the regulators on both breakers, Singleton Ridge A and Singleton Ridge B, to 120 volts. Close, open point, open, new, open point. And we'll designate those locations when we're out there in the field. All right, that's pretty much in a nutshell it. Now, listen to Professor V and I as far as the communications are concerned. You're going to be paired with somebody. Or if you want to pair with somebody, you select that person and let me know tomorrow.
Okay.
So I'm going to say right now that I'll be a dispatcher and a person here. Robbie, you're going to be at Singleton Ridge A.
Okay.
And I'll be at Singleton Ridge B, and I'll be at the dispatcher.
Okay.
Okay, so at this time, Robbie, will you ask me if you tell me you want to move the open point?
All right. I'll be 101 dispatch.
This dispatch, go ahead.
Yes, I'd like to begin my field switching orders.
Okay, I understand you're ready to begin your field switching order, moving the open point.
That is correct.
Okay.
All right.
Who's going to be at pole number 1?
I'll be at pole number 1, and you'll be at pole number 2.
102 will be at pole number 2. All right. At this time, I'm ready for you to put Singleton Ridge A and Singleton Ridge B and Singleton Ridge A and not automatic.
Okay, at this time you requested me to put SRA in the non-automatic position, and I will be at that time. I'll be at Singleton Ridge A. So at this time, SRA is in non-automatic.
Okay, I understand at this time you have SRA and not automatic.
That is correct.
Okay, I'll be at Singleton Ridge B. At this time, I have Singleton Ridge B and not automatic.
Okay,
And the dispatcher's going to confirm.
correct.
Okay?
Yep.
All right. 101 at this time, I have the regulators A, B, and C on SRE matched and to 120 volts.
Okay. At this time, you have the regulators SRA at matched at, all three matched at 120 volts and turned off.
That is correct.
Okay.
What's your status on yours? Got your regulators matched?
Yeah, regulators SRA and SRB are to 120 and they are turned off.
Right. Okay. You notice I added that to the end there.
Yeah.
Regulators have a tendency to, if you don't turn them off, they're going to try to go back and start regulating voltage again. So if you don't turn them off, it won't stay matched at 120 volts at the regulator. So turned off is vitally important. 101, this is division.
101.
I'm ready for you to close the open point.
All right. At this at this time, I have pole number 1 closed at this time.
Roger, I understand you have pole number 1 closed at this time.
That is correct.
Okay. I'm going to call myself 102. This is division 102. I'm ready for you to open the new open point at pole number 2. I understand you're ready for me to open the new open point at pole number 2. That is correct. Division at this time, I have open point at pole number 2 open. Okay. All right. That gets the process done as far as moving the open point. Then you have to put everything back to normal. All right. Regulators.
Okay.
SRA regulators and SRB regulators turned back on. Okay, this is going to happen on the radio. SRA and SRB breakers returned to normal. And that's going to have to be relayed over the radio. So, Robbie.
Yes.
At this time, we've completed field switching order 1. I'm ready for you to return the regulators on SRA back to normal.
All right. At this time, I understand switching is complete, and I've placed SRA breaker back to the automatic position.
Roger that. At this time, I have returned SRE regulators back to normal, and I have SRB breaker returned back to normal, back to automatic. And that'll end the process. So you see what's going on here as far as just moving an open point is concerned. And you guys with extension sticks will designate the pole numbers, are going to have to know, are going to have to do the actual opening and closing of switches. So that was the part of the moving, moving an open point. I just want to give you a heads up of what's going on there as far as the process is concerned. It's going to take a little practice. And that's why we built it that way out in the field. And we'll start working on this with some people tomorrow. If you got somebody that you want to join with to get this process done, what happens at the end of this, and I'll show you what goes on, is I save all the recordings. So we're going to use what they call, and this is part of your homework today, not your test work today. Let me unshare this. And start another share. I wish my mouse was in the right place. Okay, you should see my American signalization come back up again.
Correct.
All right, move that. Everybody's got a phone, right?
Yeah.
Okay. You're going to go to Zello.com and you're going to download Zello onto your device. Now, the thing I like about Zello here is if you're not conversing or you're not listening to a conversation, you're not using any bandwidth. All the other ones, are using bandwidth. Download it to your device. And once you have it on there, it's going to ask you to have a username tied to your email address. Use whatever email address you want to. Just make sure that you check your email address. And if you don't do that, you're unable to talk. So you're just going to confirm by email that you've downloaded and installed it. And once you have it installed, let me get back over here. ZELLOCHANNELS, Hello Channels.
Can you see my screen?
No, I don't see your screen because I'm sharing mine.
Walkie talkie.
Okay, that was the wrong one. You're gonna go. Come on, my keyboard is slow. Well, that didn't do it right. Inside the software, because we can't install software on these computers. Inside the software, once you get it out, there's a channel search option. And guess what you're gonna search for? Santee Cooper. Now, even though we've got that name on there for that channel, it's only exclusive to us. Nobody from Santee Cooper is on it. Some other old classmates are. But you're going to join the Santee Cooper channel. After you've joined the channel, and we'll mess around with it on the field tomorrow. After you've joined the channel, I need to approve you. And once you're approved, you'll be able to talk walkie-talkie with us and do the switching part over a radio type situation. Please use a name that's understandable. Okay, I'm not going to let in Obi-Wan Kenobi. You know, if your name is Kyler Swires, put K Swires or Kyler Swires or, you know, Blake Brown, whatever you're going to be putting in there as far as that's concerned, so we know who you are. Okay. I am actually, and if you want to mess through it through the course of the day, let me see, I should be in a channel already. Yeah. Yep, I'm in the Santee Cooper channel now. With who else? Ian. Causey Ellis?
Yeah.
Causey's in there too.
Okay.
So if you run into bumps in the road today, don't worry too much about it. Just get it installed, and when we meet at the field tomorrow morning, we can square away because, you know, we'll be able to see each other's phones and talk to each other. Okay, any questions?
Can you see me in there? I think I
I
did it.
see you in there. No.
I think I did it. Add.
Connect to this channel, sign into your account on Zello.com and verify your email address.
There you go. You got to verify. That's the verification process.
Okay.
All right. Anything else with questions? Stand by one moment. Get unshare here. Why is this covered up? Stop share. All right. Scott, did you get my text?
Oh,
What was that?
was you talking to me?
Your name's Scott.
You mean on Remind or like to my
Yep.
regular number?
Yep, both, either. What? Okay, everybody but Scott, I'm finished unless you have further questions. Professor V, anything?
You went over the